An exploit back in 2003 known as the Slammer worm took down 75,000 of Microsoft's SQL and desktop engine servers in 10 minutes using a single packet. So how did it do this? In our code, we have a normal packet with our instruction, our values, and our null terminator, and our handle request call here. But if you take a look at our handle request function, the issue is down here when we copy the actual name into the instance, there's no bounds check, so the copy can just go on forever. This is known as a buffer overflow, a very common exploit that I'm sure you've heard about before. This single line copies name into instance, but without the bounds check, it can keep copying until it hits another null character within the memory. When that will be, you have no idea. But what if you could control when it stops? That's where our payload comes in. Here I made a payload packet of element size 376. This is just an arbitrary number that I chose, but in reality, all you need is enough room to overwrite the return address of the function where we can cause some real havoc. So at payload 0, we're taking the same command instruction that we had up in the normal packet and we're putting it at the front. From here, I'm doing a simple memset where all of our values are just going to be 0x41, which is the letter A, and we're setting almost all of our elements to that letter. And then at the end, we put a null terminator character, which is where we can control when that write stops. This is how the exploit works. It overwrites the memory past it, and one of these areas is going to be our return address for our function. Now, of course, GCC has safeguards for this, but if we compile it using no safeguards, then we run it,